It can be argued that the big three, as far as security services is concerned, are protection of confidentiality, protection of data integrity, and protection against impersonation. Now, we have already seen how WPA and WPA2 provide better confidentiality and data integrity protection than WEP. What about protection against impersonation, namely user authentication? How do they handle that, and how do they improve on WEP as far as authenticating the user is concerned? Let's recap first how confidentiality and integrity are protected in WPA and WPA2, and how they are protected more securely in these schemes compared with WEP. So recall that WEP uses RC4 with a poor usage of keys, and the ICV that's meant for integrity protection is a linear 32-bit CRC, not a cryptographic CRC. In WPA, RC4 is still used, but it's with better key mixing and per packet keys in a scheme known as TKIP, Temporary Key Integrity Protocol. As the name suggests, it's temporary, and then also the key usage is improved, so the key integrity is improved, therefore temporary key integrity protocol. Then Michael is used for integrity protection. In WPA2, things are enhanced even further with the use of a very strong block cipher known as AES, Advanced Encryption System. As it's a block cipher, it needs to be used in certain modes to convert it to a stream cipher. So it's used in counter mode for confidentiality and in CBC MAC for integrity protection. Now then, what about authentication? It would appear, we have already seen how 802.1x helps to solve authentication problems. So it would appear that we could just use 802.1x in Wi-Fi, and that would solve all our authentication problems. And then we can stop right here. However, there's also other considerations that the Wi-Fi Alliance takes very seriously, and that is how easy is it to use Wi-Fi? Because it can impact the Wi-Fi market negatively if it's very difficult to set up and to configure Wi-Fi systems. So there are certain ease of use considerations that the Wi-Fi Alliance has considered, and because of these, then in home or small office Wi-Fi networks, there are some alternatives to using 802.1x. There is WPA PSK and also WPA2 PSK, where PSK stands for pre-shared key. So instead of using 802.1x, we use a pre-shared key, and this is known as personal mode. And another solution arising out of ease of use considerations is WPS, which we will talk about in the next video. So in this video, we'll focus on comparing personal mode with so-called enterprise mode, which is actually using 802.1x and is more secure. In personal mode, there is a pre-shared key that the whole BSS shares. Any new device can come into a network and be granted access as long as it has the shared key. Authentication and access are then based on knowledge of the shared key. If a device has its shared key, then it will be allowed to use the network. This is convenient for home users, but clearly it's not a best practice as far as security is concerned. There's also another convenience that has been put in place, and that is instead of entering a key directly, a user can enter a passphrase. So it can be a shared passphrase rather than a shared key that is entered all the devices and the access point. And then there are some algorithms to convert from passphrase to the actual key itself. Generally, these algorithms are okay, and so we don't see specific attacks based on the fact that we're using passphrases rather than entering the keys directly. Another thing to note is that the pre-shared key is not used directly, but it's used as the so-called pre-shared, the pairwise master key. Pairwise meaning between the transmitter and receiver is a pairwise master key from which the transient key is derived. As we saw in the block diagrams for both WPA and WPA2, there is a transient key which is used as one of the inputs rather than the pairwise master key. This is better than WEP, where the key is used directly for encryption. Still, because of the sharing of the key among so many different devices, it's not really a good way to do authentication. Enterprise mode is the better way, and that uses the 802.1x model that we saw in a previous video. One of the benefits is that individual authentication credentials are used then. It's not sharing a key. EAP is flexible as mentioned before, so you can use different ways to authenticate the user, or maybe the user's phone in the case of SIM card identity. EAP does end-to-end communications, and some of the methods even provide for mutual authentication, which is better than just authenticating the client, because then it protects against man-in-the-middle attacks. Some EAP authentication methods provide a secure tunnel for legacy username and password authentication protocols that might not have that inherently. The pairwise master key is per session, and only the supplicant and authentication server can generate it, which is a secure way of doing things. So it's generated upon successful authentication, and the server passes it back to the access point. So much better than using personal mode.